Hello everyone. Today we are going to see about a basic circuit analysis in which we are going to see the topics called series circuits, problems in series circuits, parallel circuits and problems in parallel circuits. Let us first start with series circuits. Okay, in series circuit, first we'll start with an example. Here this is called as this is called a series circuit, an example. So how we are saying this as a series circuit? Okay, so when you just imagine a train, okay, where the compartments, the coaches are connected one behind the other. Similarly here, the resistor R2 is connected behind R1, resistor R3 is connected behind R2 and resistor R4 is connected behind R3. Okay, and here, so here as the resistors are connected one behind the other, this is called as a series circuit. The circuits, the resistors are connected in a series fashion. Okay, so here we will take the example of the series circuit as a 4 resistors connected with the battery, where battery is voltage. Okay. So under the series circuit, what are the things that we are going to see here is how to calculate the total current, how to calculate the resistance of the given series circuit, what is the voltage drop across all the resistors in the given circuit. Okay. Okay, when you see here the resistor, when you see here the current here is stated as the current is same in a series circuit. How you are saying that the current is same in the series circuit? So let us take in this case. Okay, so here let us take the current. We all know that the current flows from higher potential to lower potential. So let us take in this case the current flows from a battery of positive potential V to the battery of potential negative potential V. Okay, so when you see this yellow color path, this is my current flow. See, there is no branching of current. That means what are the currents that are flowing from the positive terminal ends with the negative terminal. Okay, see, the current flows from the positive terminal ends with the negative terminal. Okay, so here there is no division of current, so we can say the current in the given circuit is same throughout the operation. Okay, so here I1 is equal to I2 is equal to I3 is equal to I4. So from that we can say I1, I2, I3, R4, I4 are all equal in a series circuit. So in a nutshell, what we can say is, in a series circuit the current is same. Okay, then we will go for voltage. Okay, when you see the voltage, okay, when you see the voltage here, see the voltage is we all know that the energy can neither be created nor be destroyed. Okay, so here the energy given here is, let us assume here this is the energy given by the battery, which is voltage, and the energy dissipated by the battery is by the resistors are V1, V2, V3 and V4. So what we can say is, no energy can be created and no energy can be destroyed. That is, V is equal to, that is the total voltage V is equal to V1 plus V2 plus V3 plus V4. So in a nutshell we can say, or we can write that Vt is equal to, the total voltage is equal to V1 plus V2 plus V3 plus V4. No energy can be created, no energy can be destroyed. So what are the voltages you are applying here is dissipated across R1, across R2, across R3 and across R4. Okay, so this is my total voltage. Okay, and then we will see about the total resistance. So what are the things we have seen here? The total current, the total voltage. So that the current is same across the circuit and the voltage is V1 plus V2 plus V3 plus V4. When you see here the resistor, in order to calculate resistor, let us rewrite the equation. Vt, we will keep Vt as it is, and we will write V1 as I1 R1. How we are writing it as I1 R1? So we know according to Ohm's law, V is equal to I into R. Okay, so according to Ohm's law, it is V is equal to I into R. So I am writing here for V1, I am writing it as I1 R1. For V2, I am writing it as I2 R2. For V3, I am writing it as I3 R3. And for V4, I am writing it as I4 R4. So here, when you're writing the total voltages, current into IT into RT, and you're writing the V1 as I1 R1, V2 as I2 R2, V3 is I3 R3, and V4 is I4 R4. How you're writing it as I into R? It is V is equal to I into R. So that's why I'm writing it as V is equal to IR. Okay, we all know by equation 1, we can write by equation 1 we can write it as we can write the current are equal. Okay, so we can say if the current are equal, we can, as the current is same, all the currents can be written as IT, and IT is cancelled. Okay, instead of I1 I2, I am writing it as I1. So therefore in a nutshell we can say RT is equal to R1 plus R2 plus R3 plus R4. So from equation 1, what we can say, that the current is the same, the current is same in all the circuits, the voltages are different, and the total resistor is RT, which is the summation of all the resistors. Okay, so so now which is different, the current is the same and voltages are different. So I'm going to find out the total voltage present in the given circuit. Okay, so let us take it as V. Okay, so what is the total, what is the voltage available in the circuit? It is V1, one voltage is V1, another one is V2. Okay, another one is V3, another one is V4. Okay, so here first let us find out what is V1. Okay, so we know it is V1 is equal to, V1 is equal to, we are writing it as I1 into R1. How you are writing it as I1 into R1? It is because of Ohm's law you are writing it as I1 into R1. So I am writing it as I1 into R1, where we know the current is same, therefore IT into R1. So when you are writing it as total current into R1, you replace the current as V by R. So it is a VT by RT. Okay, so here RT is equal to, when you are writing it as the resistor, RT is equal to R1 plus R2 plus R3 plus R4 into R1. So we know what is V. You are just, that is, I repeat, V1 is equal to I1 R1. Why? How you are writing it as I1 R1? You are writing it as, because of Ohm's law, you are writing it as I1 into R1, and the same can be written as IT into R1, where you can write the total current as total voltage by total resistor. You keep the total voltage as it is and write the total resistor as R1, R2, R3 and R4. So this is V1. So for V2, how, what you will write? For V2, I will write it as V2 is equal to, what is V2 here? V2 is equal to I2 into R2. Okay, so I am writing it as I2 into R2. So instead of I1, I am writing it as I2 into R2. So instead of I2, I am writing here as, I am writing, instead of I2, I am writing it as replace with this VT by RT. Oh, this can be seen in the following equation. See, it is I2 R2. Instead of I2, I am writing it as VT by RT. What is my RT? It is a summation of all the resistors. So what is a V2? It is the total voltage by the total resistor into the corresponding resistor. Okay. Similarly for V3 we can write it as total voltage by total resistor into the corresponding resistor. Similarly for V4 we can write it as total voltage by total resistor into the corresponding resistor. Okay. So this is about series circuit. So in a series circuit, what are the things we have seen? It is the current is same in a series circuit. The voltage is the current is same. Okay, the voltage is different and RT is the summation of the resistors. So from that we have seen voltage division rule. Now we will see a problem related with the series resistor. So in we have here, what is the question? The question is we are going to find out the total resistance, the total current and the voltage developed across each resistor. You take the input voltage as 10 volt. Okay, the circuit here is we have connected 3 resistors in series, 5 ohms, 5 ohms and 10 ohms, and the voltage here is, this is given in the problem, which is 10 volt. Okay, so here R1, R2 and R3, they are connected in series. How you are saying that as a series? They are connected one behind the other, just like the train compartment. Okay. So here, now the first question is you have to find out the total resistor. What is the total resistor? We know from the previous slide. We know the total resistor is the summation of all the resistors. That is, the total resistor is R1 plus R2 plus R3. Okay. So here we are going to insert, so we have to add all the resistors in order to find the total resistance. Then what is my next step? My next step is to find out the current. Okay, so in a series circuit the current is same. Okay, so the voltages are different. The current is same here. IT is equal to R1, I1 is equal to I2 is equal to I3, and in a series circuit the voltages are different. It is VT by the total resistance is RT. It is a summation of resistor. The current is the same current and the voltages are the summation of the voltage. Okay. So first let us find out the total resistance. The total resistance is R1 plus R2 plus R3, which is 10 plus 5 plus 5. So 10 is given over here, 5 plus 5. Okay. So it is 20 ohms. Okay, so this is my total resistance. Okay, now so the first one is over. In order to find the total resistance, it is R1 plus R2 plus R3. Just add the resistors. Okay, now we will go in calculating. We will go for calculating the current. Okay, so in in a series circuit, the current is same, which is equivalent to the total current. Okay, so what is my total current? We know by Ohm's law, V is equal to I into R. Okay. So what is I? I is equal to V by R. So the current is the same here, which is V by R. Okay, if it is a total current, we can write it as IT is equal to VT by RT. So what is my total voltage here? It is 10 by the total resistor. What is my total resistor here? 20. So it is 10 by 20, which is 0.5 amps. Okay, so we have found out the total resistance, which is the summation of all the resistor. Okay, we have found out the current, which is VT by RT. VT is given in the problem 10, RT is given by the equation number 3, it is 10 by 20, which is 0.5 ampere. Okay, so this is my total current. Now what is the next one? What is the voltage developed across each resistor? So when you see the voltage developed across each resistor, from the previous we can use voltage division rule. Okay, so what is voltage division rule? It is the total voltage by the total resistor into the corresponding resistor. Total voltage here is 10. The total resistance is 20. How you are writing it as 10 by 20? The total voltage is given in the circuit 10. Okay, and the total resistor is it is given by the equation number 3. It is 20 ohms. So Vt by Rt into the corresponding resistor, which is 5 ohms here. Similarly, we can calculate for V2. For V2, it is Vt by Rt, which is 10 by 20 into the corresponding resistor. Similarly, for V3, it is V2 into R2 and into R3, the corresponding resistor. So thus we can calculate all the things, that is the total resistance, current and voltage developed across each resistor. Okay, next we are going to see about parallel circuits, where we will similar to series circuits, we are going to see what is a parallel circuit. Then we will see what is the total current consumed in a parallel circuit, total resistor, voltage across the different resistors, and the current across each branch. So these are the things that we have seen. We'll see first an example for a parallel circuit. You can imagine an auditorium or a cinema hall where we can have the a single entry point and the same exit point. That is, all the people will enter into through a single entry point, and all the people will exit through the single exit point. Okay, so in a circuit, in parallel circuits, the current flowing through R1 and R2, they will the current flowing through R1 and R2, they are entering through this single point. Okay, and similarly the current exiting from R1 and R2 are exiting through the single point. That is, the starting point and the end point of both the resistors are same. If it is like that, we can say the circuit is a parallel circuit. So parallel circuits are the circuits in which their starting point and the ending point are same. Okay, so this is same in a parallel circuit, the starting point and the ending point. In a series circuit, it is one behind the other, just like a train coach. In a parallel circuit, it is like imagine an auditorium or a cinema hall where the entry and the exit point are same. Okay, so this is an example for a parallel circuit. Okay, so first we will see about what about the voltage is present in the parallel circuit. We know the voltage, or we know the voltage. Let us take the voltage across R1 is V1, and let us take the voltage across R2 is V2. Okay, so here when you see this, both the positive polarity, the positive polarity, the resistor R1. Okay, when you see this, the positive polarity and the resistor R1 and the resistor R2, they are all connected to the same point. Okay, when as they are connected to the same point, we can say they are connected at the same point, and the exit of the battery and the exit of the resistor R1 and the exit of the resistor R2, they are all connected in the same point. As they are connected in the same point, we can say that the circuit is parallel, and also the voltage drop across R1 is at the entry point it is plus VB, and at the exit point it is 0. Similarly for R2, the entry point of R2 is plus VB, the exit point of R2 is minus VB. Okay, so here across R1 and across R2 it is the same voltage. So in a parallel circuit the voltages are same. Okay, the parallel circuit the voltages are same. In a series circuit the voltages are different, the current is same. Okay, so in a parallel circuit the voltages are same. We will see how what is the current here, and when you see here the current is okay, when you see here the current is, let us assume the current the I is branched into I1, and similarly some current flows through R2. Okay, so we can write it as the total current is equal to I1 plus I2. Okay, so here the total current is I1 plus I2. In a series circuit the current is same, the voltages are different, you remember. In a parallel circuit the voltages are same but the current is different. Okay, and then we will see about the resistor. Let us take the resistor, we can rewrite the Ohm's law as I is equal to V by R. I is equal to V by R. So using this Ohm's law equation, we are rewriting the equation number 2 as Vt, It is can be written as Vt by Rt, and I1 can be written as V1 by R1, and I2 can be written as V2 by R2. Okay, so in the parallel circuit we know the voltages are same, therefore all get cancelled. The voltages are same, they are get cancelled, and our total resistor is 1 by RT is equal to 1 by R1 plus 1 by R2. Okay, so here in a parallel circuit the voltages are same. In a parallel circuit the current is different, and the resistors can be written as when you take the equation number 2, you can rewrite it as Vt by Rt is equal to V1 by R1 plus V2 by R2. The voltages are same. Okay, so you can cancel the voltage. When you cancel the voltage, it is 1 by RT is equal to 1 by R1 plus 1 by R2, which can also be written as R1 plus R2 by R1 into R2. The total resistor is just, it is 1 by RT. So you have to take the reciprocal of equation number 3. You take the reciprocal of 3. So from that we can find it out. It is R1 into R2 by R1 plus R2. Okay, now the voltage is same, the current is different, and the resistance. Now it is time to calculate what are the different currents, I1 and I2. Okay, so it is the same circuit. The same current is divided into I1. It is again divided into I2. Okay, so let us first calculate I1. For that, in a series circuit, it is a voltage division rule. In a parallel circuit, as we are dividing the current, it is called as current division rule. Okay. So it is, we can rewrite the equation I1 as, we can rewrite the equation I1 as, so we all know the total current is equal to I1 plus I2. Rewrite the equation. It is Vt by Rt, I1 is Vt by R1, I2 is V2 by Vt by R2. So I1 is equal to, what is by Ohm's law, we can write it as V1 by R1. Okay, so you keep R1 as such. V1, the voltage is same, so you are writing it as V1 is equal to, we are writing V1, the voltages are same, so you can writing it as V1 is equal to Vt. Okay, what is the total voltage? We can write it as Vt is equal to It RT. Okay. So I am writing it as IT into RT. So when you are writing it as IT RT, you keep IT as it is. We know from the equation number 3, we know RT is equal to R1 into R2 by R1 plus R2. Okay, now R1 and R1 get cancelled. So it is the total current IT divide by the total resistor. What is the total resistor here? R1 and R2 divide by the total resistor into the resistor into R2. R2 is, see here you are going to find out I1. Okay, the resistor opposite to I1 is R2, right? So it is the total current by the total resistor into opposite resistor. Okay. Similarly, we can calculate for I2. It is again V2 by I. Current is equal to, by Ohm's law, we are writing it as V2 by R2. Okay. By Ohm, by you keep R2 as such. You take V2. V2 is equal to, by Ohm's law, we can write it as current into resistor. And here it is V2. Okay, here you are writing it as T, because the voltages are same in the parallel circuit. Okay, so you are writing it as IT into RT by R2, and you are writing it as you keep your IT as it is. Okay, and what is my RT here? R1 into R2 by R1 plus R2 divide by R2. R2 and R2 get cancelled. So it is the total current divide by the total resistor into R1. R1 is not the same resistor. It is opposite to R2. Okay. So it is, what is the current division rule? It is the total current by the total resistor into the opposite resistor. Okay. In voltage division rule, it is the same resistor. We will see a problem related with the parallel circuit. So what is a parallel circuit? The resistors are, it is, the voltage here is 10. Okay, the resistors are 10 kilo ohms. Okay, so the resistors are connected in a parallel fashion. So what is a parallel fashion? The entry point and the exit point are same. Say they are connected parallel to each other, and the potential is, the total battery potential is 10 volt. Okay, first the question is the total current and the total resistance. So we know the formula for a total current, total resistance, and the current in each branch. Let us do it one by one. So in a parallel circuit, we know the voltages are same. So what is the voltage given over here? It is 10 volt. Okay, so V1 is equal to V2, which is equal to 10 volt. Okay, so the voltages are same, and then we'll find out the current in each branch, and we can find out the total current, the total resistance, and all. We know the formula for total resistance is, it is R1 into R2 by R1 plus R2. So you just multiply all the resistors. It is 10 kilo ohm, so 10 into 10 power 3 into 10 into 10 power 3. So when you see this, the total resistor here is 5 kilo ohms. Okay, thus total resistance has been found out. So the total resistor, we have a formula R1 into R2 by R1 plus R2. Okay, the next is total current. So we know by Ohm's law, I is equal to V by R. What is my V here? It is 10 volt. So I am writing here as 10. What is my resistor here? It is 5 kilo ohms. So I am writing it here as 5 kilo ohms. So what is my total current? It is 2 milliamps. Okay. So the total current and the total resistance has been finished. Then find the current in each branch. See, for finding the current in each branch, we have the formula. So we are going to apply it. It is the total current into, the formula here is the total current into the total current divided by the total resistor. Okay, so it is given over here. It is the total current then it is a total resistance. Okay, IT by RT into the opposite resistor. So in order to find I1, you have to see the opposite resistor. What is the resistor opposite to R1? It is R2. So it is R2. Multiply it by R2. So here when you are doing this, you substitute the formula and you will get it as 1 milliamps. Similarly, the current in the second branch. Current in the second branch is the same formula. Instead of R2, the same formula. It is the same formula, IT by RT. Instead of R2, you have to write it as R1. Okay. So see here, instead of R2, we are writing it as R1. So this is my current in the second branch. Okay. Now we will see one more problem with the parallel resistor. See, in the previous problem we have seen only what is that? We have seen only two resistors. Okay. We are going to see now three resistors. See here we have connected three resistors. They are in parallel with each other. Their entry points are 2, 3, 4. They are same, and their exit point are 7, 5, 6. All are same. Okay. First, let us find out the total current, total resistance, and the current in the each branch. Before getting into that, we know that the voltages are same. See here the voltage is same, which is 9 volt. Okay, then the total resistance. What is my total resistance? It is 1 by RT is equal to 1 by R1 plus 1 by R2 plus 1 by R3. You do it and take the reciprocal. When you take the reciprocal, it is 1.6 into this is 1 by RT is 1.6 into 10 raised minus 3. When you take the reciprocal, the resistance, total resistance is 625 ohms. Okay, then find the total current. That is the first question, which is I is equal to V by R, Ohm's law. Because of Ohm's law, it is a VT by RT. Okay, so it is, what is my voltage is 9 volt and my resistance is 625. So you divide it, you will find out the total current. Total resistance has been found out, the total current has been found out. Then the current in each branch. So in the current in the each branch, we know it is if it is I1. Okay. See here there are three resistors. Okay, so you couldn't apply current division rule. For two resistors we can apply current division rule. So as there are three resistors, it is we use the famous Ohm's law. It is V by R. Okay, so here it is, what is my V here? The voltages are same. Okay, so it is 9. What is my resistor first? It is 10 kilo ohm. So I1 is equal to 9 by 10 kilo ohms. Okay. Similarly, we can calculate for I2, I3 and I4. I2 and I3. It is 9 by 10 kilo ohm for the first case, then 9 by 2 kilo ohm, then 9 by 1 kilo ohm. See here, 9 by 10. Second branch 9 by 2 kilo ohm. Third branch 9 by 1 kilo ohm. Okay, so this is we have found out the total current, the total resistance. For total, the voltage is same in the circuit. The total resistance is 1 by R1 plus 1 by R2, and the current is when you see the current, it is V by R. So we are finding it as V by R. Okay, so if it is two resistors, if we are having only two resistors in parallel, you can go for current division. Otherwise you have to do like this. Thank you.